2.2 Calorimetry. For the lecture, we only discuss about 2.2a heat capacity and specific heat capacity. Heat capacity, we using capital letter C. So the meaning is amount of heat required to raise temperature of a given quantity of substance by 1K or 1 degree Celsius. Heat capacity equal to the Q over different temperature. So different temperature, we can calculate difference between temperature final and temperature initial. So the unit of heat capacity is Joule per Kelvin or Joule per degree Celsius. For the specific heat capacity, using the lowercase c, so the meaning is amount of heat required to raise temperature of 1 gram of substance by 1 Kelvin or 1 degree Celsius. Specific heat capacity is equal to Q over M over different temperature. So the unit of specific heat capacity is Joule per gram per Kelvin or Joule per gram per degree Celsius. For example, for the water, specific heat capacity of water equal to 4.18 Joule per gram per Kelvin. That means we need 4.18 Joule of heat to increase the temperature of 1 gram of water by 1 Kelvin. Okay, the concept of heat transfer. Heat is a form of energy which flow from high temperature object to a lower temperature object when they are placed in thermal contact. That means the heat release is equal to the heat absorbed. So that the heat release equal to heat absorbed. So heat release plus heat absorbed equal to 0. The quantity of heat absorbed by an object is proportional to its temperature. So using the symbol Q proportional to the different temperature, or Q equal to the C times different temperature, where C is heat capacity of a substance. Okay, how to calculate the Q? To calculate the Q, we can use a simple formula Q equal to MC delta T or Q equal to C delta T. Okay, where Q equal to heat release, M refer to the mass of substance, C refer to the specific heat capacity or heat capacity and different temperature. Example, calculate the amount of heat needed to increase the temperature of 250 gram of water from 20 degrees Celsius to 56 degrees Celsius. Given specific heat capacity of water is 4.18 Joule per gram per degree Celsius or per Kelvin. Okay, how to solve the problem? By using the simple formula Q equal to MC delta T. Fill which correct data given. M equal to 250 gram, C equal to 4.18 and delta T difference between 56 minus 20K. So we got the answer 37.6 kJ. That means amount of heat needed is 37 kJ. Example 5. A calorimeter contains 400 milliliter of water at 25 degrees Celsius. If 600 milliliter of water at 60 degrees Celsius is added to it, determine the final temperature. Assume that the heat absorbed by calorimeter is negligible. So, answer the problem. Okay, given mass of hot water 600, mass of cool water 400. So by using the concept of heat release by added water equal to the heat absorbed by cool water, so Q equal to MC delta T for the heat release equal to the Q equal to MC delta T for the heat absorbed. Okay, fill with data given. So we got the final temperature equal to 46.0 degrees Celsius. Okay, for the exercise 3, calculate the specific heat capacity of copper given at 204.75 joule of energy raises the temperature of 15 gram of copper from 25 degrees Celsius to 60 degrees Celsius. Okay, you can try answer this exercise question. Hess's law. So learning outcome for the Hess's law. State Hess's law. So what is the meaning of Hess's law? Hess's law states that when reactants are converted to products, the change in enthalpy is the same whether the reaction takes place in one step or in the series of steps. For example, reaction A to produce B, given the enthalpy delta H1. So the reaction A to C given the enthalpy delta H2, and the reaction C to produce B given the enthalpy delta H3. So by using the Hess's law, delta H1 equal to the sum of series of steps. That means delta H2 plus delta H3. 2.4 Born-Haber cycle. Learning outcomes. First, define lattice energy and electron affinity. Second one, explain the following effects on the magnitude of lattice energy. First, ionic charge. Second, ionic radii. The meaning of lattice energy. Lattice energy of formation refer to the energy released when 1 mole of solid ionic compound formed from its gaseous ion. Formation, that means solid compound formed from the gaseous ion. For example, formation of sodium chloride solid from gaseous ion of sodium plus and gaseous ion of chlorine minus. So the lattice energy refer to the minus 771 kJ. Okay, the second lattice energy, define of lattice energy of dissociation. So refer to the energy required to completely separate of 1 mole of a solid ionic compound into gaseous ion. That means 1 mole of sodium chloride solid dissociated to form sodium ion in gaseous state and chlorine ion in gaseous state. So the lattice energy is positive 771 kJ. Okay, the magnitude of lattice energy increases. That means more negative or more exothermic. So the first reason is the lattice energy increase when the ionic charge increases. The ionic charge increases, the stronger the attractive force between the ion. For example, the ionic charge of lithium plus and fluorine minus compared to the ionic charge of magnesium 2 plus and oxygen 2 minus. The ionic charge of magnesium 2 plus and oxygen 2 minus higher than ionic charge of lithium plus and fluorine minus, so that the lattice energy of MgO is higher than lattice energy of LiF. Okay, the second reason is the ionic radii decreases. The smaller the ion, the closer the distance between the two ions. So the stronger the attractive force between the ion. For example, lithium plus with fluorine minus compared to the K plus and bromine minus. So the lithium plus and fluorine minus smaller ion compared to the K plus and bromine minus. So the smaller the ion, the stronger attraction, the higher lattice energy. So lattice energy of LiF higher than lattice energy of KBr. Okay, example, which substance MgO or Na2O has a larger lattice energy? Explain. Okay, the lattice energy of MgO higher than lattice energy of Na2O because first, ionic size of Mg2 plus smaller than Na plus, and the second one, the charge of Mg2 plus bigger than charge of Na plus, so that the attraction between MgO stronger than Na2O. Okay, electron affinity. The meaning of electron affinity: energy change when 1 mole of gaseous atoms gains 1 mole of electrons to form gaseous ion. For example, fluorine gas atom to produce fluorine gas ion, oxygen gas atom produce oxygen gas ion, or oxygen gas ion to produce oxygen gas 2- ion. The meaning of ionization energy. Ionization energy. First ionization energy is the minimal energy required to remove an electron from a gaseous atom in its ground state. For example, gaseous X atom to produce gaseous X positive ion. Okay, the second ionization energy is the minimum energy required to remove an electron from a gaseous positive ion in its ground state. For example, X positive ion to produce X2 plus ion. Okay, that's all for chapter 2.